So first thing I'm going to do is draw that diagram. So my center pole, objects traveling around in a circle, and it's going to make some angle with my center pole, an angle of theta, and my theta is going to be equal to 30 degrees. I'm going to draw a free body diagram of the ball that is rotating around here. So I'm going to say my ball, which is my lovely little dot, it exists on Earth, so it's going to experience a force due to gravity pointing down. It's also going to experience a force due to tension due to the fact that there is a string attached. We know that the angle in from there is going to be 30 degrees, so we would have a 30 degrees in there. Parallel lines say it's going to be on the other side as well. The ball is traveling around in a horizontal circle, so that means the sum of the forces in the y is going to be equal to 0. Very good. So our sum of the forces in the y is going to be equal to 0. We have two forces acting in the y. We have a gravitational force pulling it down and a tension force pulling it up. But the tension force is not all of that. There is a vertical component as well as a horizontal component. So in this situation, I'm going to take the cosine of 30 degrees. So ft, and I'm going to end up with cosine of theta minus my force due to gravity. I'm then going to rearrange this and solve for Ft, because I don't know what the force of tension is going to be. Fg is equal to mass times gravity. So we're going to get mg on cos theta is going to be equal to my force of tension. The sum of the forces, or the net force in any object that is traveling around in uniform circular motion, is equal to mv squared on r. So the sum of the forces in the x, which is the plane at which my circle is rotating, my object is rotating, is going to be equal to mv squared on r, which is then going to come from what force? Ft, right? The force of the tension is the only one that is pointing towards the center, but it's not all of it. There is only a portion of it, and that is the sine of 30 in this regard. So it's going to be Ft sine of theta. But I have a value now for Ft, don't I? Ft is equal to mg on cos theta. So I can substitute that in. So I'm going to get mg on cos theta sine theta. Sine theta on cos theta is tan. So I'm going to get mg tan theta, but the problem is I've also got an m on both sides, so the m's cancel and disappear. We get v squared on r is then going to be equal to g tan theta. What else don't we know? We don't have the radius, but we do have a triangle. So if we go and look at our triangle, we've got a length of our triangle, the hypotenuse of the triangle as being 1 meter. Our 1 meter long component there, it's got 30 degrees in there. That means we're after our radius here. R is then going to be equal to 1 times sine theta. I can now substitute that in. Moving it over to the other side as well, I will get my v squared is equal to 1, I'm not going to bother writing in there, so I'm just going to get g sine theta tan theta. Take the square root of that, so I'm going to get the square root of g sine theta tan theta, which is then going to get me the square root of 10 times sine of 30 times tan of 30 degrees, which should come out as being equal to about the 1.7 meters per second.